Hello and thank you for joining us. My name is David Hall, Product Marketing Manager with National Instruments. And today we're going to talk about measurement speed for wireless LAN signals. Now the two systems that we're going to use today include a PXI vector signal generator and vector signal analyzer solution. This uses the 6.6 gigahertz instrumentation suite from National Instruments. The controller we're using is a PXI-8106 dual-core controller. And one of the things that we're going to find is that the high performance of dual-core controllers allows us to achieve significantly faster measurement times than with traditional instruments. Now the traditional instrument we're using today is the Agilent N4010A, which is one of the most common wireless LAN test systems on the market. So what we're doing is we actually are using our PXI vector signal generator, and we're splitting our signal out to a PXI vector signal analyzer, and then as well to the N4010A. Now the benchmark we're going to perform today is 100 measurements of an EVM measurement. Now you can see on your screen that I'm configuring this for the Agilent N4010A. I'll configure 10 averages per measurement, 16 OFDM symbols per measurement, and then we're going to look at the average time over 50 measurements. Now I'll just click on Run right here. As you can see, the test system I'm using is actually controlling the N4010A through a GPIB cable. We're using GPIB in this case because it has the lowest latency bus versus LAN and USB, and we'll add the smallest amount of overhead to total measurement time. And you can see it's running the measurement. The front panel of my N4010 says that this instrument is currently being remotely operated, and of course it's being controlled by the PXI instrument. Now our measurement result just finished. You can see that my residual EVM was about negative 38 dB, and my average power was about negative 15 dB. And the measurement time is 476 milliseconds. Now what this is reporting is that it took 476 milliseconds for each EVM measurement, and that EVM measurement consists of 10 averages. Averaging is important in production test. In this case we're seeing an average measurement time of 476 milliseconds for that measurement. So next, I'm going to run the exact same setup using the PXI instrumentation. Again, I'll configure 10 averages, 50 measurements, and then I'll click on Run. Now in this case, I'm using the 5663, and using the Wireless LAN measurement suite, I'm also reporting the constellation for the measurement as well. You can see that it already finished the result. If I look at my statistics, the mean measurement time for each measurement was 60 milliseconds. That's almost 8x faster than the N4010A. In addition, my mean EVM was negative 44 dB, which is about a 6 dB improvement against the N4010A. So what this measurement benchmark shows us is that PXI instruments, based on the Wireless LAN measurement suite, allow you to perform wireless LAN EVM and even spectral measurements significantly faster than traditional boxes. In this specific benchmark, we saw the 5663 perform measurements about 8 times faster. That's 60 milliseconds versus 475. In addition, it's also performing these measurements significantly more accurately than the N4010A, where we look at negative 38 dB for the N4010 and negative 44 dB for the PXI instrument. So we hope this provides you a little bit of insight into the measurement speed improvements that you can observe in PXI instrumentation. For more information, please visit ni.com/RF.